All right, so welcome back to lesson 26. We're on to the next section. We just finished our warm-ups. So this is all about the triangle congruence proofs, right? So we've been working on those for a few days. Now we're just focusing on kind of like seeing how isosceles triangles can be used in a proof. So I'll give you a moment, kind of mark up your picture as we normally do, and then we'll go through it together. So you can pause the video now, mark up your picture, see if you can kind of see anything in the picture and what we're looking for to get these two triangles congruent. So pause now and then come back later. Okay, so hopefully you're coming back now from having marked up your picture. Let's just run through it quickly. So there are some things going on here that are new, again, with isosceles triangles. So one is that they're telling us that it's triangle ABC, isosceles, and they're telling us the base. So sometimes they do this when they don't want to necessarily tell us any pieces. They're just kind of laying out the land for us, meaning they can't just tell us ABC is isosceles and have us assuming who the congruent sides are. So they're telling us that the AB is the base, because now we know if he's the base, we can figure out, oh, these two guys must be the congruent sides, and these two guys must be the congruent angles. So that's kind of a nice bonus, because once they tell you something is isosceles, you get not only two congruent sides, you also get two congruent angles. So that's a beautiful thing. The next thing they tell us is that this is a segment DE. If you remember, we talked about this the other day, why sometimes they do that in a proof. Again, just some proof styles are different, but sometimes it's a hint for something that we may be using. Let's keep that in mind. And then they tell us that DA is congruent to EB. Now we're trying to prove DAC. Let's get a little highlighter action on that. DAC, this guy over here, is congruent to EBC, this guy over here. So again, we're going to take a walk around those triangles and kind of see what we have so far. So far we have these sides here, BE, so this one here, and we have this one here, BC. So we have BE and BC, like in this triangle. And then we don't really have much else going for us. These two triangles are not sharing a side. They don't have any vertical angles. But we do have these little guys over here, the 2 and the 3. Now, the problem is 2 and 3 are not inside the triangle. They're outside of the triangle. So the struggle would be that we could, if we kind of see that 1 and 2 are supplementary angles, 3 and 4 are supplementary. If 2 and 3 are congruent, that means that 1 and 4 must also be congruent, because what's that theorem again? Supplements of congruent angles must be congruent. So now we've got ourselves a side, BE, an angle, 4, and another side, BC, in that triangle, and then the coordinating pieces in the other triangle. So I feel like we're all ready to go. So at this point, you should write up your proof. You can pause the video when I tell you to, and just write up your proof, and then come back and check that you have the same thing that I have. Great.